For today, what we're going to look at are two different formulas. And we could just give you the formulas right off the bat, but I'd really like to make sure you understand how they're derived, where we got them from. So before we do anything else, just want to make sure we understand a little bit of vocab. What is a line segment? A line segment is just that part of a line that has two endpoints. We're very used to that. Midpoint, though, you might not be as familiar with it, but it sounds kind of just like what it says. It's the point exactly in the middle. So if there's a halfway point between you and your friend's house, that's the midway point, right? The midpoint. Important that we understand that that's what a midpoint means. A segment bisector is actually a line that cuts another line in half, right? So it's a line that cuts that second one directly in the middle, or aka at the midpoint. So in a second, we're going to give you these formulas, but in order to do it, you may not think it's possible, but I still want to do a DESMOS activity. So if you want to join me after the fact, obviously you can't do this live with me, but you could still join the class and work through it on your own time. So if you go to student.desmos.com, your code is going to be AT6JXH. So join that Desmos activity. You can press pause and get logged in there. And then once you do, you should see a screen that looks like this. So what I want to do here first is just help us understand how easy distance really is, even though it appears to be quite challenging. So if I were to ask you to estimate the length of that segment, you should be able to just almost look at it. And because it's on a graph, you can click on these points, right? Because it's on a graph and it's a straight horizontal, the key there is it's a horizontal line, we could just try to give it an estimate. So I'm just going to say, well, that's about maybe 4, right? We'll share that with the class if you want to. From there, let's estimate this one. Again, I'm going to say that one's about 5, or maybe, yeah, let's go with 5. Share that with the class if you'd like. And then moving on to example 3, let's estimate this one. Let's see. How do I estimate this one? So the question kind of comes in, is that going to be 2, 3, 4, maybe? Something like that. So the question is, well, what's the difference between example 1, example 2, and example 3? Well, hopefully you've noticed example 1 was a horizontal line right there. Example 2 was a vertical line right here. And it should go without saying, but just in case, anytime it's a horizontal or vertical line, we can just count the spaces on the graph. So I estimated it was 5. I think I was off. So if I count here, it's 1, 2, 3, 4, 5, 6. So the correct answer should have been 6, right? I was just guessing. Here, if we count all the way from -5 back to -1, or vice versa, go the other direction, we're going to be left with 4, right? So that one I did get correct. But when we get to example 3, we now have no way of actually counting this. If you try to count and say that's 1, that is definitely not 1. You can't just count. I'm going to draw on this picture here. So you can click on this and draw on it. You can't say that that's 1 and then 2 and then 3. That just does not work. The only way you can count is if it's a horizontal or a vertical line. So what I want to show you is I want to show you what's called the Pythagorean theorem method for actually deriving the length of that particular line. So you can see here that I've got a picture, and the 2 points of this orange line are at -2, 4 and 0, 3. We're trying to figure out what that orange distance is. But to do that, we create a right triangle. So that's why we're going to be using the Pythagorean theorem. Because when we create a right triangle by drawing a line straight down and then a line straight across, we've now created a right triangle that allows us to use the Pythagorean theorem, and we can plug in our values and derive what that actual approximate distance is. So let's actually figure out what this distance is. This one is not, these are not the correct numbers for this example. It's just an example. But let's actually derive what these numbers are. If we count down here, okay, if we count down on this screen, 1, 2, 3, 4, right? So that's going to be our distance down is 4. So I'm going to go ahead and I'm going to start by typing the square root sign because we're going to have to take the square root of it eventually. But it's going to be 4 squared plus, count across, 1, 2, 3, 4, 5, 6, 7, 8, right? We probably could have figured that out just by going from, let me grab that there. So that should have been at 0, 3, and then this point right there is at -2. Actually, that is the right number because this is way zoomed in. I now understand what's going on. Because it was zoomed in, this is actually -2. So our counting is completely off. You're going to have to forgive me on that. So let's count this again. If we count it correctly, this point right here is -2, 3, and this point right here is -2, 4. So that's actually only 1. We went up from 3 to 4. So that's going to be 1. You can see that it was 1 squared. All right. Plus, and that is going to be 2 because this is over here at -2. This is at 0, or at least it was. Okay. It was at 0. And so that's just going to be 2 over, so 2 squared. So 2 squared. And that gives us our approximate distance there, or square root of 5 is 2.2. All right, so hopefully you're starting to see how this works. And for the next examples, what I want you to actually do on your Desmos activity is draw it in. So this graph is a whole lot nicer than that other one. Let's go ahead and draw in. I'll use a couple different colors here. Draw in our sides, and I'm going to use the line tool to make it nice and straight. So if I go straight, I can go straight across. I don't necessarily have to go straight down. So straight across. What's the distance of that? 1, 2, 3, 4, 5, 6. So that distance there is 6, right? And then straight down to get our next line, straight down, and we'll count that as well. So if we count that, that's going to be 5 plus 2 more gives me 7, right? So this is going to be 7. And so to actually do our calculations, we start with the square root, then 6 squared plus 7 squared. Right? Remember to keep it all underneath the square root, and that means that our actual length of that segment is about 9.2. 9.2. So pretty cool way of actually figuring out the distance of a segment that is not a vertical or a horizontal line. So I'm going to let you keep trying that on your own time. There's another example there for you to try. And so sometimes it's interesting to be sure that when you create your coordinates, you're realizing that what you're actually doing there is you're just doing some subtraction, right? You're just doing some subtraction. So if I went back to example 5, what I'm actually doing is I'm just kind of counting, I'm subtracting. In this case, it was -5 minus 1, and that gives me -6, but it's the distance, so it's +6, right? So what I'm going to help you see now is where we're going to actually create this formula from. The Pythagorean theorem method is actually my preferred method, but if you don't have it on a graph, it's a little bit more challenging. So I want to show you how we can create our actual Pythagorean theorem distance formula here. So you'll notice that in this particular case, the length of the bottom, right, if we draw it on, is 2, but that's because it was 3 and 1, right? Our x-coordinates are 3 and 1. So if I do 3 minus 1, that gives me the length of the bottom of my triangle is 2. And the height of my triangle, the length of the side is 3, because it was at my y-coordinate was 5, and my y-coordinate was 2. 5 minus 2 gives me 3. So that's actually, there's our Pythagorean theorem. 2 squared plus 3 squared, take the square root, square root of 13, right? So 3.6, right? But let's actually do this in the same way, but help you see how it's actually a formula. And this is where we're going to get back to our notes, is that the distance formula is the second x minus the first x squared, right? Just like we did right here. We took the second x, 3, minus the first x, 1, and that gave us the length of our side. So when we take that second x, the the first x, we subtract them, and then we square that, because that's our a squared, so to speak, of the Pythagorean theorem. And the same thing happens for the vertical distance. Our second y, in this case it was 5. That was our second y, 5. And our first y, 2. We subtract 5 minus 2. And that gives me 3. So then we square that, 3 squared. So it's really important that you see that when we plug these values in, it works out very nicely no matter how you do it, right? So whether it's subtraction, whether you get a negative, the squares take care of everything for you. So it's actually pretty cool. The distance formula is born from the Pythagorean theorem. So I want us to practice. I'm going to do this one with you real quick to make sure you're okay. But I want us to practice typing this in. So you start by typing the square root sign, SQRT, and then open parentheses, and then our second x. So our second x in this case is this -7. So -7 minus our first x, -2. So minus -2. You'll notice that I have two negatives there, right? I have two negatives there because the minus comes from the equation, but then this was a -2, so that's okay. We're allowed to have two negatives there. And then right next to the parentheses, we're going to square it. So remember, I'm pressing Shift 6 to get that squared. Now make sure you stay inside the parentheses, or rather inside the square root, plus another set of parentheses. Now my y's. My y to here was also -7, minus my first y was +3. So -3. And then we Shift 6, square it as well. So there you go. We just found the distance. It's 11.2 if you round, 11.2. So I'm hoping that this is starting to click for you. You're starting to see how this process comes together, but you've got to be able to choose whatever method works for you. If you like the Pythagorean theorem method, you could do that as long as you have the graph to do it on, right? But if you don't have the graph to do it on, like here, you could use the distance formula and plug it in. Whatever method you prefer it's quite up to you. So take your time if you want to keep practicing some of these. There's lots of examples here for you to work with. You could use the Pythagorean theorem. You could use the distance formula. And then make sure you answer the reflection question if you have any questions still about it. Okay? I want to come bring us back to the notes, but I'm going to give you a second to move on to the next video.